In Lesson 4.5, we're going to be writing equations of parallel and perpendicular lines. So you might want to pause the video and copy the title. We've talked before in previous chapters about the fact that parallel lines have equal slopes. So if the slope of one line is 3/4 and it's parallel to another line, well, the only possible slope for the other line is 3/4 because the slopes must be equal if the lines are parallel. So what we're going to be asked to do in this lesson is to write equations of lines if we're sort of given a hint about them in the form of the fact that it's parallel to another line. In the guided practice example number 1 on page 258, we are asked to write an equation of a line that passes through this point and is parallel to this line. Y equals -x plus 5. Well, remember, when y is by itself, this is y equals mx plus b form. So whatever number sits in front of x is our slope. We'll always see in front of this particular x is a negative sign, but remember, that just means we have a 1 there. So our slope is -1. And that's the first thing you're going to want to determine. So since the line we're looking for is parallel to this line, it shares the same slope, but it's going to go through this point they gave us. So what they've really done is they've given us a point and a slope by telling us that the line was parallel to this line. So we've got m equals -1, and our point is -2, 11. So point slope form. Y minus blank equals blank times x minus blank. So we'll go in and put the slope in front of x. We'll put the x coordinate, which is always the first number in the point, over here with the x. The y coordinate, which is the second number in the point, over here with the y. And we've got our rough version of the equation. But since we've learned to put these in slope-intercept form, we're going to clean this up and then put it in slope-intercept form. Let's go ahead and begin in our effort to put this in slope-intercept form by distributing this -1. -1 times x is just -x. -1 times this number here, but we have to pause because we're back in that situation we keep encountering where we have minus and negative, and remember that just cancels to this being the same thing as x plus 2 on the inside. So we're distributing a -1 to a +2, so we're going to get a -2 there. The only thing left to do is to pull this -11 over to the other side, and remember our shortcut, if it jumps the equal sign, it changes signs. So we have the -x minus 2 already there, and now we're going to add to that plus 11. Well, this gives us a pair of like terms on that side that we need to combine for our final equation, which is y equals -x, and -2 plus 11 gives us plus 9. So that's the correct equation. Let's look at another example. In fact, why don't you pause the video and see if you can use the previous one as an example and see if you can do this problem before viewing the solution. Have you tried it yet? If not, let's do it together. So we're going to write the equation of a line through the point -3, 3 and parallel. Remember our symbol for parallel is 2 slashes. Parallel to this line. And again, we have a y equals mx plus b equation. So the number that's in front of the x is our slope, and that happens to be -2. So this statement is really kind of a code or a hint to tell us that m in this problem equals -2. So we've got our slope. They gave us this point. So we're going to use point slope form. Y minus blank equals blank times x minus blank. Then we fill in our blanks. Slope goes in front of x, so I put the -2 here. And then I go to my point, and the first number is x, so it goes over here with the x. The other number is y, it goes over here with the y. If you notice, we had the minus negative again, so we remember that's just plus a +3. And if we're going to put this in slope-intercept form, we're going to distribute that -2 first to each thing inside. And remember, since we're distributing a negative, each thing inside is going to change signs. Well, currently they're both positive, so that means they're going to both end up negative. -2 times x is -2x. -2 times +3 is -6, so that's going to give us a -6 there. We've still got the -3 over here with the y. We've got to pick this guy up, toss him to the other side, and remember, when he crosses the equal sign, he becomes positive. Gone now, so we have y equals -2x. We have this -6 plus 3 that we can combine, and that would give us -3. And that's the equation we're looking for. Did you get it right? The other concept that we're going to look at is similar to this one, the idea of lines being parallel, but now they're going to be perpendicular. And perpendicular lines, instead of having equal slopes, will have negative reciprocal slopes. So if the slope of one line is, say, 1/3, then its perpendicular would be -3/1. If the slope of one line is 2/3, then its perpendicular, got to flip it upside down and make it negative, makes it -3/2. Let's see how this looks on the graphs of two perpendicular lines. On the left, we have a line that has 2 points plotted for us to look at. So let's take a look at our rise. So we're going to rise from the first point. So we're going to rise up 1, 2, 3, 4. We went up 4. So the slope of this line has a +4 rise. And then we're going to run 3 to get to the second point. So the slope of this line is +4/3. And remember, we can tell that it's positive because the line is going up. Now let's come over here and do the same thing with the line that's perpendicular to the line on the left. If I start at this point, I'm going to go down this time. Let's try that again. Go down 1, 2, 3. So that means my rise is -3, and my run is 4 to the right, which gives me 4 as my run. So the slope of this line is -3/4. So when two lines are perpendicular, the rise of one will be the run of the other, and there'll be different signs. Let's look at the guided practice example number 2 on page 259. We have 3 lines here, and we're asked to determine whether any are parallel or perpendicular. To decide if they're parallel or perpendicular, we need to know what the slope is for each. So that's what we're going to go through and do. Well, at a glance, it looks like B over here is our best friend when it comes to figuring out slope, because it's already in slope-intercept form. So we know that the number in front of x is our slope, which means the slope of this line is 3. 1 down, 2 to go. Well, the magic of this one came from the fact that